Okay, so today basically we're doing a small lecture on linear algebra. Well, this is just a tiny, tiny, tiny bit of linear algebra. So we're basically going to cover two things: how to solve systems of linear equations most efficiently, and also I'm going to remind you how to do determinants of matrices of any size. Already, when we talked about second order equations, we did this for, let me try to focus this a little better. Excuse me for a sec. Okay, hopefully that focused it a little better. Let me try that one more time. It looks a little blurry to me. There we go. Okay, so we did determinants of 2x2 matrices before many, many weeks ago. It's all kind of seems to be quite far in the past. But now we need to talk about determinants for bigger matrices and remind you how to do those. Okay, let's first do systems of linear equations. Now, this isn't linear differential equations, just systems of linear equations. And how to solve them. Well, first, let's write down a system of linear equations. So let's say x1 up to xn are unknown, but we have these equations: a11 times x1 plus a12 times x2, and you keep going till you get a1n times xn equals, let's call it b1. And the next equation we'll call a12 x1 plus a22 x2 plus a2n xn equals b2, and you keep going like that. And maybe you have m of these equations, so the last one will look like am1 x1 plus am2 x2 plus so on to amn xn equals bm. So here the ai's, aij is a constant. So I, the way we've written it, goes from 1 up to n, 1 up to m, sorry, and j goes from 1 up to n. So you think of this as the first one is telling you which equation it's in. This equation we'll call the first equation. Here we'll call this one the second equation. This one we'll call the mth equation. So it tells you which equation it's in is the first subscript, and the second one tells you what it's the coefficient of. So in other words, let's pick one out of the middle. A12 is in the first equation, and it's the coefficient of the second variable. Okay? And also the bj's are constants. Okay, and so those are all given to you. All right, and so you have m equations. Let me turn my other colored pen. So we have m equations. And notice we have n variables. So m and n don't have to be the same size, okay? So you can have 3 equations in 5 unknowns, or 8 equations in 10 unknowns. But the best scenario is when you have the same number of equations and unknowns, then you have the chance at having a unique solution. You can also have more equations than unknowns, But there it's getting harder and harder to make you have a chance at having a solution, because think of each equation as constraining things. So that means you have more constraints than you have variables to accommodate those constraints. And so in that case, it becomes more difficult to have a solution, but it's still possible. You just have to do the math and see how things work out. Okay, so when you first start studying systems of equations in high school, you know those, and you learn very simple ones like 2 equations and 2 unknowns at first, and so on, 3 equations and 3 unknowns. And as soon as you get to 3 equations and 3 unknowns, it gets messier to solve. Because trying to do stuff, so for example, if we had easy equations, let's say we had x1 plus x2 equals 3, and 2x1 minus, let's say 5x2 equals 6. Okay, so that's 2 equations and 2 unknowns. Now you could solve it by substitution. You could say x1 is equal to 3 minus x2, and then you could put it into this into this equation. So you would say 2, instead of writing x1, you would say 3 minus x2 minus 5x2 equals 6. And so we would have 6 minus 2x2 minus 5x2 equals 6. And so that would give you that minus 7. Whoops, let me make sure to keep seeing it. Minus 7x2 equals 0, which would say that x2 is 0. And now you could plug it into either one of those equations. Let's use this first one. So we could say x1 plus x2 is 3, but x2 is 0, so that says x1 is 3, and you'd have your solution. Okay, but as soon as I go to a bigger system, let me pick a decent one to work out, because some of these numbers can get very messy. The arithmetic can get messy sometimes. Okay, so as soon as we go to a bigger system, for example, let's look at x1 minus 2x2 plus 3x3 equals 7. And that's our first equation. And then we have take minus x1 plus x2 minus 2x3 equals minus 5. And then you could do 2x1 minus x2 minus x3 equals 4. Okay, so here's another example. So you have 3 equations and 3 unknowns. Okay, so we'd like to solve it and find out if there's an exact x1, x2, and x3 that satisfies this equation, or is there no solution, or are there many solutions? So we're going to look at 3 examples where we see each one of those cases happen. Okay, now what if you tried to do this by the methods of high school algebra? That is, say, use some equations, eliminate one of the variables. It takes forever. Well, not really forever, but it certainly takes a long time. Even if you know Kramer's rule and memorize it, Kramer's rule takes a while and it's messy to remember. So neither one of those 2 are a good system, in my opinion. So what's the best way to solve? Okay, and the answer, I believe, and most people believe, is using something called Gaussian elimination. Okay, so what is Gaussian elimination? Basically, it's a systematic way of doing things where you're actually using the rules of algebra, but you're doing it inside a matrix, so it seems much simpler because you don't have to worry. It's easier to keep track of what's going on. So here's the rules for Gaussian elimination. And some people call it Gaussian reduction. It just basically depends on where you stop the elimination. Okay, there are only three. And what you are allowed to do is to, first thing we want to do is we want to write this system, right. So what we think of this as our system, star. So write star as a big matrix. So I'm going to write things down. I'm going to write just the coefficients of x1 in the first column, just the coefficients of x2 in the second column. Maybe I need to bring this in a little bit to make it a little bit bigger. It might have been a little hard to see the way it was. All right, this might be a little better, even though you see the base of my camera. Okay, let's refocus. Okay, so then I'm going to write the coefficients of x3 in the third column, and then what comes after the equal sign. In other words, my first row is going to be 1, -2, 3, 7. And my second row is going to be -1, 1, -2, -5. And my third row will be 2, -1, -1, 4. Okay, so that's what I call the big matrix. The technical term for that is the augmented matrix. Okay, so the augmented matrices, you do exactly that. Just write the coefficients in a row. Okay. And once we do, now we want to start to use the rules of Gaussian elimination to simplify things. First off, what are the rules of Gaussian elimination? First, we can interchange two rows. Okay. Now that's not surprising. That's nothing to be surprised about, because all that says at the level of equations is you've moved the equations around. If you switch two rows in this guy, all that means is you maybe switch the order of two equations, which you can do. You can write them down any way you like. That's not a problem. Okay. Now, what's another rule? You can multiply any row by a non-zero constant. Okay, and why is that not a surprise? Because multiplying any row by a constant, remember, a row corresponds to an equation up here. So if I multiply everything in the equation by the same constant, on this side by the distributive law, if you multiply everything in the equation by the same constant, then you haven't changed anything. That's just the way the algebra goes, by the distributive property. This is still not very good. Just a little too big. There we go. Okay, and what's the third rule? We can combine these two things. We can multiply a row by a non-zero constant and add it to another row and replace one of those rows by the new row. Okay, so in other words, think about that in terms of the equations. I can multiply any row by a non-zero constant and add it to another row. What would that correspond to doing? Think for a second. Suppose I multiplied the third equation by 1. That's a non-zero constant. And then I'd add it to this row. Well, that's a legal operation, right? If you have two equations and you want to solve them simultaneously, you can multiply a row by anything because that's just multiplying across the equation and add it to another row. You knew you could do that, combine them that way from algebra. And then that gives you a new equation to work with. Okay, so let's see this method working. Well, first of all, and what's our goal? The goal is to use these row operations to go from this big augmented matrix to a matrix that looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. And then, I don't know, we have numbers here. They're not the same numbers, surely, as the ones you started with, but let's say B1, B2, B3. Okay. Why would that be the goal? Now translate back each one of these rows to what it means in terms of the equation. So remember, this column was the column that of what gets multiplied times x1. The second column is what gets multiplied times x2. The third times x3. And then this is what comes after the equal sign. Okay, so the first row, remembering that, translates to 1 times x1 plus 0 times x2 plus 0 times x3 equals b1. That is to say, x1 is b1. And these are numbers, okay? Once you've done this, you have real numbers listed over there. So this row tells me that x1 is b1. Likewise, the second row would tell me that x2 is b2. And the third row would tell me x3 is b3. In other words, if I can get my matrix to go from this form to this form, I can read off the solution. All right, now let's see it in action. Okay, so I'm just going to recopy this matrix on the top of the next sheet. Oops, you have to be able to see the top of the next sheet. Okay. All right. So now the first, when you're doing this Gaussian elimination, the first thing you're going to want to do is know your left hand from your right hand. I think we can all manage that. Okay, so you want to start at the leftmost column, and the goal is to get the leftmost column to look like this first. Okay, so first we try to get the left-hand column to look like 1, 0, 0. And whenever you're working, no matter which column you're working on, it's very important to get. So work column by column. And work left to right. Get the 1 first and use it to get zeros. Now, if you're slick and you're very good with arithmetic and stuff, you can kind of avoid some of the fractions that are going to come up when you do this method of getting the 1 exactly first. But I want to teach you one method that works all the time. You just have to do the arithmetic, okay? It's not hard, it's just tedious, and you have to be a very good bookkeeper. So if you're messy and you don't like to write things down, this is going to be really tough for you. But if you just So don't be messy and don't be afraid to write out the steps in between and to keep track of what you're doing. If you do your bookkeeping well, you can't miss on this. This is some of the easiest stuff you'll ever have to do in math. Okay, so now our goal is to get it to look like this. Now, when I say I want to get the 1 in the left-hand column first, lucky us, we have a 1 there already. So we don't really have to do anything to get the 1 in this upper left-hand corner. So I just copy the first row. So I got the 1. Now I want to use it to make a 0 appear here and a 0 appear here. So how will I do that? I can multiply the row by, I'm going to multiply row 1 by something. I'm going to use that row 1, multiply it by something, and add it to one of the other rows to make the 0. Well, to make a 0, if I added these first 2 rows, all I have to do is add row 1 and row 2. And the way I keep track of what I'm doing is I make notes to myself on the outside of what I'm doing. I'm taking row 1 and I'm adding it to row 2. Okay, so then I do that entry by entry. So 1 plus 1 is 0. Minus 2 and 1 is minus 1. 3 and 2 is 1. 7, that's a 7 up here. 7 and minus 5 is 2. Okay, so we got the 1 and we used it to get a 0 here. Now we have to get a 2. We want to make that turn into a 0 using the 1 in this column. How do I do that? If I want to add something to 2 and get 0, it better be minus 2. So I'll take minus 2 times row 1 and add it to row 3. And the reason I do that is when I take minus 2 times 1, I get minus 2. When I add it to plus 2, I get 0. You do it entry by entry in this method, always. And now whatever happens along the rest of the calculation, just live with it. Minus 2 times minus 2 is plus 4, and I add it to the 1. So that gives me 3. Minus 2 times 3 is minus 6, and I add it to minus 1, that's minus 7. And then minus 2 times 7 is minus 14, and I add that to plus 4, I get minus 10. Okay. So now my first column, it looks great. Now I want to get the second column to look like 0, 1, 0. So the first thing I have to do is get the 1 in the correct place in the second column. And right now, in that second column, I have a minus 1. I want it to be a plus 1. What do I need to multiply row 2 by to get it to be a plus 1? Well, shouldn't be hard to figure out. I want to multiply it times minus 1. So that will be 0, 1, minus 1, minus 2. Okay. Now, when you're first learning how to do this, it might be a good idea to just recopy all these rows. Okay, just so till you get the feel of this. And now in the next matrix, what you want to do is use the row that already looks good with the 1 in the correct place to make the zeros in the places you would like to get them. So for the second column, I want to get the 0 in this slot and a 0 in this slot. Okay, so that means I have to take to get the minus 2 to be a 0, I'll multiply row 2 times 2 and add it to row 1. Remember, all I care about is to get that zero in the right place. So now when I do that, I carry out the operation. 2 times 0 is 0 and added to 1, that's 1. 2 times 1 is 2, added to minus 2, it's 0. That's why we picked multiply by 2. Okay. Minus 2 times, 2 times minus 1 is minus 2 and added to 3, that gives you 1. And 2 times minus 2 is minus 4, and I add that to 7, that gives me 3. All right, Now in this one, we want to take a -3 and turn it into a 0. What do we add to -3 to get 0? I mean, sorry, I gave the answer away while I was saying that. What do we add to 3 to get 0? You add -3. So I want to take -3 times row 2 and add it to row 3. Okay. Hope you can see that when you look back at this. So when I do this now, I get 0 times -3 is 0. Add it to 0, I get 0. -3 times 1 is -3, and +3 is 0. -3 times -1 is +3, and I add it to -7, that's -4. -3 times -2 is +6, and I add it to -10, that's -6. I'm sorry, +6, and you add it to -10, that's -4. Okay, you gotta be a good bookkeeper, and you gotta do your arithmetic right. That should be a -4. Okay. All right, and so now the first two columns look great. Now we gotta make our third column. Now we gotta make our third column look like the form we want. A 1 at the bottom and then 2 zeros above it. So what do we need to do there? So we need to turn this -4 into a 1. So what do? I multiply the third row by -1/4. When I do that, I will get 0, 0, 1, 1. Because when I multiply by -1/4, I get 1 here, and this was a -4, so when I multiply by -1/4, I get +1. Okay, let's see, I might have this. Adjust the camera again. Okay. Okay, so now we've got the 1. Again, I could copy this matrix again. Well, maybe for today I'll do that, or at least for this problem, I'll recopy these rows. But quickly you'll learn how to do it where you don't have to recopy that part. You just start using that new row. Anyway, now we will use the new 1 here to get rid of what? We want to make this guy be a 0 and that would be a 0. Okay. So to get rid of a +1 in row 1, I need to multiply row 3 by -1 and add it to row 1. Remember, that's the point in getting the 1 in the column in the right place first. And then you use that 1 to clear you multiply that 1 by something to get your 0 in the place you want it. So -3 times 0 is 0, plus 1 is 1. Again, you have -1 times 0 plus 0 is 0. -1 times +1 is -1, and I added to the 1 here, that gives me 0. And -1 times 1 is -1, and I added to 3, that gives me 2. Okay. And now to get rid of the -1 here using a +1, I just add those two rows. I say row 3 plus row 2. I don't have to multiply row 2 by anything to make it that work. So now when I add those rows, I say 0 plus 0 is 0. 0 plus 1 is 1. -1 and +1 is 0. And 1 and -2 is -1. Okay. And now we remember, we have exactly what we want. We have the 1 0, the 1 0 0 0 1 0 0 0 1, and then stuff. And the stuff are our answers. Because when I remember that this first column are the coefficients of x1, the second column are the coefficients of x2, the third is the coefficients of x3, and then this column is what comes after the equal sign. And now I translate. So this row says 1 times x1 plus 0 times x2 plus 0 times x3 equals 2. In other words, it says x1 equals 2. And the second row is going to tell me by the same idea that x2 is minus 1. And the third row will tell me that x3 is 1. So that's your answer. The solution to that equation, where did I write my original problem? Up here. So the solution, that looks hard to see. So the x1, x2, x3 that satisfies this system of equations right here is x1 equals, what did we find? It's, the solution is 2 minus 1, 3. So the answer is, let me use it in red. So the answer is x1 equals 2, x2 is minus 1, and x3 is 1. Okay. And you won't find a simpler way to solve these, a quicker way once you get used to it. Once you get used to doing this, you can go very, very fast on this. Okay. All right, let me show you another thing. So sometimes we know that systems of equations don't have solutions. That just happens. So let's look at another system of equations where we won't have a solution. Well, I shouldn't have given the result away, but suppose I look at the system x1 plus 2x2 minus x3 equals 1, and 2x1 plus x2 plus x3 equals 1, and x1 minus x2 plus 2x3 equals 1. Okay. So you want to solve this system. All right, so we're going to use this Gaussian elimination because now we know the trick and it goes pretty fast. So I'm going to write my matrix. My matrix will be 1, 2, minus 1, 1. Just copying coefficients. 2, 1, 1, 1. 1 minus 1, 2, 1. So this is when I really miss not being in front of you guys, so that I can't say, does everybody follow? And usually people need a little reassurance that they're understanding this. So I hope you are following this along, and that by having the video so you can go back and re-look at it if you're confused about something, you can see it again and maybe it makes sense. And also remember, we're going to meet on Monday in a Zoom for questions, so you can ask me questions about the videos too if you have any at that time. Okay, so let's see. Now we want to go ahead and do our row reduction. I should mention sometimes when you learn this, to emphasize that what part is the coefficients and part is what comes after the coefficients, people often put a little line there. So you can do that too if that makes it look better to you. Okay, so now again, we're lucky we have a 1 in the right position, so we don't have to do anything on the first one. So we just recopy that first row, and then we're going to use that 1 in the upper left-hand corner to get rid of the 2 and the 1. So to get rid of the 2, I will say minus 2 times row 1 and add it to row 2. Because to clear that first column, we always want to use row 1. Always row 1 to clear the first column. Minus 2 and plus 2 will be 0. Minus 4 and plus 1 is minus 3. Plus 2 and 1 is 3. And minus 2 and 1 is minus 1. Okay. And now to clear the 1 using this, we have to say minus 1 times row 1 and add it to row 3. Okay, so that'll be -1 and +1 is 0. -2 and -1 is -3. Then we will get +1 and 2 is 3. And then we will get +1 and 1 is 2. Okay. All right. And so now the next step would be to get this, we want to get the 1 in the right place in the second column. And where's the correct place in the second column for the 1? It's right in that middle. So we're going to say -1/3 row 2. And yeah, you're going to have to deal with fractions if you want a consistent method, but they're usually, that's life. It'll brush up on your arithmetic skills. That's good. So we'll get 0, 1, -1, and then we'll get 1/3. Okay. And then let's go ahead. Now we've got to make this, we have the 1 in the right place. So now we want to get rid of the 2 and the -3. We want to, what I mean by get rid of them, I want to make them be zeros. So let's try to get rid of the -3 first. So here I'm going to show you the trick I use because it saves a lot of writing. So I'm going to use this row 2, my new one that's fixed with the 1 in the correct place, the one I like. And I'm going to use it to get rid of the -3 and the 2. So I'll have to work from this row 2 and add it to numbers from in row 3 and row 1 from this matrix. So in other words, I'm going to say here, I will multiply this row 2. So right here, I mean the new one. That is this one, the new row 2 times 3 and add it to row 3. And that's from the old matrix over there. Okay, so we sort of work between the two. Saves you a little bit of writing. If that confuses you, you can always go ahead, recopy row 1 and row 2, and then go to a new matrix. And then you'll probably begin to switch after a while because you'll get really used to this method and it goes, it seems like a lot at first, but this is really very simple and very quick once you get used to it. Okay, so let's go ahead and do this. So we take 3 times this row 2. 3 times 0 is 0, and I'm going to add to this row element from row 3. So 0 plus 0 is 0. 3 times 1 is 3, and I'm adding it to this -3. So that will give me 0. 3 times -1 is -3, and I'm going to add it to this 3. So that will give me 0. And 3 times 1/3 is 1, and I add it to 2. That gives me 3. Okay. And now I'm going to stop. Why am I going to stop? Because I could go ahead and do the row 1, but let's remember when these rows always at every step of the game translate to an equation. And what does this last equation say? This says 0 times x1 plus 0 times x2 plus 0 times x3 equals 3. In other words, this says 0 is equal to 3, and that's impossible. So what does impossible mean? Impossible means there's no solution. In other words, you could never find an x1, an x2, and an x3 that would satisfy those equations all at the same time. So this method throws in your face there's no solution. How? When you see a row that turns out to be all zeros on this side and then a non-zero element at the end. Okay, when you see that, you know immediately stop, there's no solution. Okay? So for this problem, there's no solution. Okay? All right, that's the way it works. Okay. Let's do one more example where you see something almost like this, but a little bit different. And then I'll explain what that means. So the third example I'm going to do here is, let's do x1 plus 2x2 minus x3 equals 2. 2x1 plus x2 plus x3 equals 1. And x1 minus x2 plus 2x3 equals minus 1. Okay. All right, so we want to solve this system. So now we know how to get started very quickly. First, we write down our matrix. 1, 2, minus 1. I like it with a little line myself. 2, 2, 1, 1, 1. 1 minus 1, 2 minus 1. Okay, so again, we're lucky. We have a 1 in the upper corner. So we copy the first equation down. Okay. Sorry, that should be a little bigger. But to get rid of the 2, to make the 0, I say minus 2 times row 1 and add it to row 2. Sorry, I'm squeezing that in there. I'm doing minus 2 times row 1 and add it to row 2. And I'm going to place that in that second row. So minus 2 times 1 is 2, and you add it to negative 2, you get 0. Then you get a minus 4, and 1 is minus 3. And then I get plus 2, and 1 is 3. And then I get minus 4, and 1 is minus 3. Okay? And now for the third row here, what I'm going to do to get rid of this, I'll take minus 1 times row 1 and add it to row 3 and put it in row 3. So I take minus 1 and plus 1 is 0. And then I take minus 2 and minus 1 is minus 3. And then I'll get plus 1 and 2 is 3. And then I'll get minus 2 and minus 1 is minus 3. Okay. Okay, and now we want to get the 1 in the correct place in the second column. So that's in the middle row. So I do minus 1/3 row 2. Okay, and when I do that, I will get 0, 1, minus 1, 1. Okay, and now I want to use that to get rid of the minus 3 here and the plus 2 up at the top. Make those into zeros. So playing the same game down here, you would multiply this row by 3 times row 1 and add it to row 3. Okay, so 3 times row 1, if I'm going to use this 1 to get rid of this minus 3, that's what I do. So it'll be 0 plus 0 is 0. 3 times 1 is 3, and add it to minus 3, you get 0. 3 times 1 is minus 3, and you add it to 3, you get 0. 3 times 1 is 3, and you add it to minus 3, you get 0. Now, before, in the previous problem, we had 0, 0, 0, and then I forget which number it was, but it was something other than 0. And I said, oh, when you see that, you immediately stop because that's a contradiction. Because it said 0, we had a 3 here. So that said 0 equals 3, so there's no solution. This, when you get a row of all zeros, is not a contradiction. Because if you translate back, that says 0x1 plus 0x2 plus 0x3 equals 0. So that says 0 equals 0, and that's okay. So that's not a contradiction. So that does not tell you to stop. That means keep on going. Okay, so to get rid of the 2 here using the 1 in the second column, I will have to say minus 2 times row 2 and add it to row 1. So minus 2 times 0 is 0 plus 1 is 1. Minus 2 times 1 is minus 2, and plus 2 is 0. Minus 2 times minus 1 is plus 2, minus 1 is 1. And then minus 2 times 1 is minus 2, and plus 2 is 0, okay? And now the problem is, what you would like to have in our perfect world, we would like to have 1, 0, 0, 0, 1, 0, 0, 0, 1. But you can never we just say turn the 0 into a 1. Okay, you can't multiply by anything to get the 1 in the right place there. So then the question is, so what do you do? Okay, then you just translate back. This essentially tells you this an equation that's not giving you any extra information, because 0 equals 0 is a tautology, we say in mathematics. It means it's always true. So it's not, one of those equations is just an extra equation. It doesn't give you any information. So now let's translate the other two equations back and see what we do get. Okay, so for this one, when I translate back, it says 1 times x1 plus 0 times x2 plus 1 times x3 equals 0. So what that says is x1 plus x3 equals 0. So x1 is minus x3. Okay. And let's translate this other equation. We translate that one over here. Okay, so that one says 0 times x1 plus 1 times x2 minus 1 times x3 equals 1. In other words, that says x2 minus x3 equals 1. In other words, x2 is 1 plus x3. So x1 is minus x3, x2 is 1 plus x3, and x3 can be anything. So we say x3 is arbitrary. Arbitrary. Sorry, no dot there. I don't have any whiteout. So x3 can be anything. Okay. All right, so that's your solution. So what a row of zeros generally tells you, is that there's a what we call a free variable. It can be chosen to be anything. Okay, and I don't know how much. Well, if we were live, I would go into this a little bit more. But and maybe when we go live on Monday, I'll try to bring some pictures. But basically, when you look at equations, 3 equations and 3 unknown, an equation like this is the equation of a plane in space. Just like if you take x plus y equals 10, that's an equation of a line in the plane. If you look at a linear equation in 3 variables like this is an equation of a plane in space. So this is one plane, this is another plane, this is a third plane. So when you have 3 planes in space, one of 3 things can happen. When you try to look at the inner, and basically when you write down and say solve them all at the same time, you're saying where do these 3 planes intersect? Well, three types of things can happen. You can get a single point where they all intersect, which is like the first example, where we started with, oops, sorry, that's, it's hard when you're doing this and you're keeping all the pages. Let me see if I can find the page. So here was the first example, where we had this plane, and this plane, and we found exactly one point where it intersected. So if you're using point notation, it intersected in the point. These 3 planes intersect in the point 2 minus 1, 1. Okay. The second example that we did, where we got no solution, means that you have 3 planes, but they never all intersect at the same place. You may have 2 parallel planes and then a third plane that cuts across them, but that means at any place where they intersect, you get at most 2 of them intersecting and the third one's doing something else. So there's no solution for them if you ask where do they all 3 intersect at the exact same place. And then when you get an example like this, where you start with the system three planes, and you get an arbitrary variable, what that means is they intersect in a line. Because if I rewrote this a little bit, x1 is minus x3, x2 is 1 plus x3. So that means that combining this equation and this equation, you have that x2 is equal to 1 plus minus x1, because x3 is minus x1. So that says that x1 plus x2 equals 1. So the intersection is a line of the three planes is a line. Okay, so for us, it's not so important to remember what the geometry means as it is to remember the method, because, but I just thought I'd mention it because I think it's interesting, and it maybe makes things make a little more sense. So when are we going to use this in this class? We're going to use it when you have higher order equations, and then you have initial, and you have to find an exact solution, explicit solution, subject to initial conditions.